In a bold revelation, scientists claim that a new planet has been found, unlike anything we've seen before.
NASA, renowned for its groundbreaking discoveries, has recently revealed that this new planet is not only intriguing due to its size and location but also because it exhibits lights that appear to be artificial.
Are we on the verge of uncovering secrets that could change our understanding of the universe? Could this discovery mean there is life on other planets? Join us as we explore NASA's intriguing findings and uncover the truth about these extraordinary lights.
In 2007, NASA launched the Dawn spacecraft with a mission to explore some of the most intriguing objects in our solar system.
Dawn was uniquely equipped with 3 ion engines, allowing it to undertake an unprecedented journey. Dawn's journey began with a 14-month survey of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data revealing Vesta's complex surface and diverse geological history. After completing its mission at Vesta, Dawn embarked on the second and perhaps most exciting part of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and set course for Ceres, a feat that traditional chemical propulsion would have found challenging. These engines provided a continuous, gentle thrust, allowing Dawn to travel vast distances efficiently and enter into a stable orbit around Ceres. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most intriguing due to its unique characteristics. As Dawn approached Ceres, scientists eagerly awaited the first detailed images of this mysterious world. They found bright spots scattered across its surface, most notably in a large crater now known as a crater. These bright spots sparked immediate interest and speculation within the scientific community. Before Dawn's mission, the best image we had of Ceres was a fuzzy, low-resolution picture taken by the Hubble Space Telescope. Scientists knew so little about this dwarf planet, and the prospect of finally getting a close-up view was thrilling. What secrets would Ceres reveal? What new discoveries awaited? The mission promised to enhance our understanding of the solar system's formation and the role of water in shaping planetary bodies. The bright spots on Ceres are unlike anything observed on other asteroids. They appear to be composed of highly reflective material, possibly salts left behind by sublimated water. This finding hinted at the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny liquid instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about the nature of Ceres? Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres stands out from other spatial bodies in the asteroid belt because of its size, mass, unique composition, and potential for water and ice. Unlike typical rocky asteroids, Ceres has a composition more akin to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015. This moment marked a significant milestone in the mission as Dawn prepared to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn drew nearer, the images of Ceres grew increasingly detailed, offering glimpses of a world that had previously been shrouded in mystery. The first images revealed a surface dotted with craters, indicative of a long history of impacts. However, it wasn't just the craters that caught the attention of scientists and space enthusiasts alike. Among these features were mysterious bright spots that boldly stood out against the darker, rocky terrain. As the images continued to improve in resolution, the scientific community buzzed with theories about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something even more exotic? The speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer inspection revealed that the brightest spot was not a single entity but rather a cluster of several distinct spots. This discovery only deepened the mystery. The hypothesis that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of bringing water or briny liquids to the surface, where they quickly evaporate, leaving bright reflective residues. These findings challenged existing notions about Ceres,
painting a picture of a more dynamic and complex world than previously imagined. The presence of such features hinted at the possibility of subsurface water or briny pockets, which could have profound implications for our understanding of the potential for life in our solar system.
But what makes Ceres different from other planets? Ceres is an intriguing planet often described as an icy world with a rocky yet porous surface. Unlike most asteroids in the belt, which are primarily composed of rocks and metals, Ceres stands out due to its unique composition. Its surface is a mix of water ice and hydrated minerals, including clays and carbonates, which give it a distinct, less dense structure compared to its rocky neighbors. This composition suggests that Ceres has a significant amount of water. The surface layer is rocky but porous, with ice and other volatiles trapped within. This icy characteristic is more reminiscent of a comet than a typical asteroid, hinting at a history that might involve a mixture of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more fascinating aspects of its makeup. The dwarf planet is believed to have a differentiated interior consisting of a muddy mantle and a core. The mantle is thought to be rich in water ice, accounting for approximately 50% of Ceres's total volume. This mantle, likely a mix of rock and brine, surrounds a core that could be composed of a denser material, possibly silicates. The presence of such a significant amount of water ice suggests that Ceres may have once harbored liquid water, especially if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and raises intriguing questions about its potential for geological activity and the role of water in its evolution. But that's not all. The discovery of ammonia clays on Ceres implies that the dwarf planet may have formed in a colder part of the solar system and migrated inward. The presence of ammonia can lower the freezing point of water, supporting the existence of subsurface brines. These insights into Ceres's composition and history not only enhance our understanding of this intriguing dwarf planet but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, particularly when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the extreme cold environments where cryovolcanoes are found. On Ceres, the cryovolcanoes function by allowing water packed with dissolved salts to reach the surface. When this salty water makes contact with the vacuum of space, it rapidly sublimates, transitioning directly from a solid or liquid state to gas. This leaves behind bright reflective salt deposits. These salt residues form the mysterious bright spots observed on Ceres's surface. The most famous of these bright spots is located in a crater named Decatur, known as Spot 5. This area has garnered significant attention due to its high reflectivity and periodic hazes observed by the Dawn spacecraft. These hazes are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity might still be ongoing or occurred relatively recently. In addition to Spot 5, Ceres hosts several other bright spots, each with its unique characteristics. These spots are not limited to a single area but are scattered across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the dynamic and active nature of Ceres, challenging previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The surface of Ceres is dotted with a variety of craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an old surface that has been subject to numerous impacts over billions of years. Others are more well-preserved, with sharp edges and deep basins suggesting more recent impacts. Interestingly, the number of craters on Ceres is fewer than initially expected. This discrepancy hints at geological processes that might be renewing the surface and erasing evidence of older impacts. One theory is that Ceres's icy composition allows for a form of cryovolcanic resurfacing, where subsurface materials periodically well up and cover older features. This ongoing geological activity suggests that Ceres is not a static world but one that has been, and possibly still is, dynamically evolving. Further evidence of geological activity on Ceres comes from the observation of fractures, grooves, and troughs crisscrossing its surface.
These features indicate that the crust of Ceres has experienced significant stress and deformation. Some of the fractures appear relatively young, possibly only a few 100 million years old, suggesting that the crust is still active to some extent. Grooves and troughs on Ceres likely formed as the crust was stretched and pulled apart. In contrast, rows of mountains and compressional ridges indicate areas where the crust was pushed together. These contrasting features provide a clear record of the internal forces shaping Ceres. Understanding these stresses and their origins helps scientists build a more comprehensive picture of Ceres's geological history and evolution.
In addition to craters and fractures, Dawn revealed other intriguing surface features on Ceres.
The presence of large domes, possibly formed by the uplift of materials beneath the surface, further suggests active geological processes. One particularly notable dome, Ahana Mons, stands out as a solitary mountain with steep, bright slopes. This feature is believed to be a cryovolcano, providing direct evidence of cryovolcanic activity on Ceres.
Another intriguing feature is the presence of linear depressions that appear to be the result of past tectonic activity.
These depressions, known as pit chains, are thought to form when the crust of Ceres is pulled apart, creating voids that collapse into chains of pits. These pit chains are similar to features observed on Mars and the Moon, indicating that despite its small size, Ceres has experienced significant tectonic forces.